All right, good morning all. My name is Mike Moore. I work for Nokia. I'm the regional product manager for our airframe data center portfolio covering North and South America. And today I'm going to talk about the openEDGE ecosystem, the opportunities and kind of where we're at, at today as far as the adoption of this form factor. So just a quick review of the form factor. It is a 19-inch, EIA 310 compatible chassis, but it's in a short form factor, 430 or 440 millimeters deep. It's intended to go into a 600 millimeter cabinet. It's 3U high, although we do have a 2U version that I'll show you here in a bit. And it's very much meant to go into edge and far edge deployments. The form factor itself is actually modeled quite similar in dimensions to the BBU unit that we currently ship. And certainly the idea behind that was to allow it to actually be installed into pre-existing cabinets, pre-existing enclosures that have already been deployed into the field. If there's an extra 3U or 2U of space, then we could turn that into into an edge cloud site. We support both 1U and 2U sleds. It just like mentioned in previous presentations, it is all front panel or front oriented. We do have a grounding lug on the back, but that's really it. Everything else, all the cabling, power supplies, not the fans. The fans are actually integrated into the sled itself. And the reason we did that was, well, for one, to maintain all front maintenance, and two, the fact that we were opening this up to the community, we didn't really want other manufacturers that were developing sleds for this chassis to be kind of a slave or indebted to our particular fans, right? Our fan spin rates, our fan algorithms. And so, in putting the fans inside the sleds itself, it allowed everyone to, kind of design their own airflow and their own fan solution. And, we do have some, for a compute platform that can hold up to 24 core processors, we do have an extended temperature range. -5 to +45, short-term durations to +55, full NEBS compliance, including seismic zone 4 testing. Let's see, and even though it is a small footprint edge platform, we still want to maintain all of the kind of the best availability practices of a typical data center deployment, right? So no single points of failure. Dual power supplies, redundant cabling, and basically all of that. The sled itself is managed through an RMC, and I'm going to show you that real briefly. We're going to have a bigger presentation on that a little bit later, but it basically allows up to all 5 sleds in the chassis to be monitored from a single port. So one of the things we really wanted to pay attention to as well is that port space at the edge can be rare, can be at a premium. So any opportunity we have to allow something like the maintenance port to be utilized with fewer ports, simply saves additional ports out at the edge. And so where we're targeting this, certainly, being Nokia, 5G is first and foremost in our, in our thoughts. And this is actually the foundation of a press release that we had out earlier this year called AirScale All in Cloud. And this is the kind of the foundation platform for our Cloud RAN, both the DU and CU units that will be deployed, as part of our 5G Cloud RAN rollout. Certainly IoT, bandwidth, security critical types of, IoT and MEC applications. We've seen a lot of customer interest in that. Actually, our first commercial deployment of openEDGE was to an IoT customer. We kind of expected, being a telco company, that it would come from one of our telco customers, but it turned out to be an IoT application. And then the fixed access, we do have discussions ongoing about this as a platform for SIBA, virtual OLT, this type of at least the x86 sleds. They can scale down. I think we offer as little as 4 or 6 processors all the way up to 24. This also becomes a really good domain for an ARM-based solution as well. As far as public and private clouds, that we really kind of had the idea that as long as we were deploying a Cloud RAN to the edge, that we'd also give the opportunity to deploy a private cloud, or a kind of a multi-tenant private cloud, or a public cloud to the edge. It turns out that in talking to public cloud providers, many of them have customized their hardware solutions to really optimize their cloud deployment. So as far as deploying a public cloud all the way out to the edge, that's not quite realistic at this point. But offering a hybrid multi-tenant cloud, allowing operators to perhaps monetize their investment in the edge, that's certainly still a possibility. And so where we're at this point, we announced openEDGE back in April of last year at the NFE World Congress. At that point, we really put about our preparations for getting openEDGE contributed. We had a working demo here a year ago at the Amsterdam Summit and released the draft specifications, and by the end of the year we were commercially shipping these units. The first contracts came very soon afterwards. We held a very productive face-to-face workshop out in Mountain View. I think it was in February, and from that we finalized the version 1.2 of the specification, which is posted out on the openEDGE wiki right now. It is accepted, which means, as Jeff had mentioned earlier, it has all the the Gerber files, the step files, everything that a manufacturer needs to actually create their own chassis, and that's been done not once but twice, successfully. And then in second quarter, WeWin had a press release stating that they were adopting the openEDGE form factor, and then it just sort of began to cascade from there. Right, we had an ARM-based developer come on board, and I'm going to talk about all of these offerings here in just a little bit. Battery backup vendor, and then we had a second supplier announce that they were going to be doing both chassis and sleds. And by the way, all of these are, you can see them all out here in the the Innovation Lab? Experience Lab, thank you, yeah. They're all out there to, don't go now, but they're all out there to, for you to take a look at. Right? And in addition to that, I didn't cover this in the timeline. We also have 2 power supply vendors that are also contributing their specs, their designs to this ecosystem. Okay. All right. So here are the manufacturers right now that have adopted this openEDGE platform. We have Nokia, WeWin, Inventus, who's doing the battery backup solution. We have ARM, Marvell, and Ampere that are doing an ARM-based sled. We have Asus, who is, or Asus, that is doing the chassis, and they're doing a Zeon D-based sled. And then Flex, and I believe Bell is the other vendor that's doing the power supply contributions. And so to go over really quick what's being contributed, or what has been contributed, this is the the chassis itself, I kind of went over that in the introduction. It has received OCP accepted status, and the design files and everything needed to build this is out on the openEDGE wiki. The sleds themselves, they come in 1U and 2U form factors. The 1U, you can fit 5 of those into a 3U chassis. Like I said, up to 24 cores. We've been able to test out and meet our environmental specifications, so it can create a fairly dense compute platform at the edge. This also has an OCP mezzanine 2.0 card on it, and also a PCI full height, half length card. So we can also put a acceleration in there, like an NVIDIA T4 GPU, or one of the new FPGA-based solutions, which we were actually using our Cloud RAN for acceleration purposes. And then the 2U, we designed that with the ability to handle up to a full height, full length, double width card. So this kind of brings in opportunities like the NVIDIA V100 as an option that could be deployed to the edge. Do we need that level of acceleration at the edge? I think the jury's still out at this point. It's kind of intriguing to be able to do that. Something like facial recognition, or real-time machine learning, that sort of thing, being able to put that all the way out to the edge and save the backhaul, especially where you're talking about some very network heavy applications that have very low latency requirements. The rack management controller, I mentioned that was the basically it monitors the power supplies, and is also has an unmanaged layer 2 switch that's really the access to the BMCs on all the sleds. That's being submitted for OCP accepted, along with a 2U chassis. And I think that is a 2U chassis. They're just customer feedback. When we first started this out, we started with a 5U chassis. We considered a 7U, settled on a 3U, but then when we started to roll that out, we had certain customers that came back and said, we love the design, we just don't need 5 servers. We could get away with 2 servers or 3 servers. Could you save us a 1U by doing a 2U chassis? Turned out to be not a big deal to do that. And so the other manufacturer right now, WeWin, that actually has a functioning unit on display. I'd like to call somebody up that could definitely explain it much better than I do. So Gregory, if you could step up and talk a little bit about your product.
Yeah. Thank you, Mike. It is my honor to be here to have a short session introduce our WeWin product. My name is Gregory, and I'm responsible for the Edge product in WeWin. We have a new product line. Actually, EP100 means that this is the Edge Platform 100 series, and we hope that we can move with the openEDGE group to come out more products afterwards and provide more ARC solutions to the customers. And so this is a 3U short depth chassis. The detail, I will not dig into the details, but I want to address that we will host the commercial off-the-shelf nodes, the slates from different vendors to make this open system environment moving, as we would like to have more edge applications under the current 5G new environment that may come out beyond our imagination now. So the new commercial off-the-shelf slates will be a very critical approach for the openEDGE. And I want to want to address the openRMC here is that for edge applications, normally we will have to either in the cloud environment or it will be in the telco environment. As we know that openEDGE is a subgroup of the telco group. So I hope that we can, via the openRMC, we can have a better connection on both the telco environment and also the cloud environment. Okay. This is a detailed spec that we are offering now, but we have the real system in this exhibition, and not only mentioned in the keynote by Bill. We also have one system in the experience lab and one working system in Winwin's lab. So you can come to the experience lab or our booth to really look into it and feel about it. So that's all my presentation today. Thanks, Mike.
Okay, all right, thank you. Actually, I think one good thing to note about their solution is that they picked this up a little bit later than they did, so they were actually offering the OCP Mezzanine 3.0 spec in their servers, which is a really nice enhancement. And so moving on, we have Asus next. They're also doing a 3U sled, or I'm sorry, a 3U chassis, along with a 1U sled. The sled itself is going to be Xeon D based, and they can do up to 16 core processors. We've actually got some really good feedback from various customers that this for lower density far edge applications would actually be a preferred architecture, going with the Xeon D solution instead of an SP. And then moving on to ARM, basically ARM, Marvell, and Ampere, who's I think probably the newest OCP member right now, have collaborated on an ARM-based solution. And this particular solution is using a Thunder 2X processor from Cavium, and I believe up to a 32-core platform. So it's creates a very core-rich, dense ARM-based solution. Then several months ago, Inventus Power contacted us and wanted to know about what they could do as far as a solution for openEDGE. It turns out that in the specification we reserve the first slot, the one just to the right of the power supplies in the RMC. We actually reserve that for a battery backup option. And Inventus was able to come in and do propose a battery backup solution. I know it says 3 to 5 minutes of continuous power, but I think you're actually getting a little better than that, or predicting a little better than that. And of course, if this went into a 2U sled, with only two 1U sleds of up to 800 watts, you would certainly get a longer holdover time with that. But certainly being designed to all of the specifications of the chassis itself, -5 to +45. They have a 5-year lifespan on the cells themselves, and so especially for for very far edge solutions where you might not have any sort of centralized battery backup, this will give you in a brownout situation or a temporary power outage situation, the holdover time, hopefully the grid recovers. But if it doesn't, it'll give you the ability to at least gracefully shut down the platform before before it runs out of power. And then from Flex, we do use 2,000 watt power supplies in this solution, and they will be donating their their spec. And this is basically in both AC and DC solutions. We find out it that you'll get a mixture of specifications for power, based on where they're being deployed, either 110, 220 AC or negative 48 volt DC. And again, this certainly meets all the specifications and requirements of the openEDGE environmentals. And so the call for action, we're basically looking to continue to expand the platform. I think there's still a lot of opportunities. Certainly additional SLED solutions. I'd look at maybe the next most critical thing would be to have an integrated switch. Maybe a 12 to 16 port, 100 gig integrated switch, I think would be a fantastic addition to it. And then I don't think too far on the heels of that will be some sort of storage solution that would be needed. Perhaps some sort of, at least, my thoughts would be a dense NVMe-based, maybe EDSFF type of solution, front panel hot swappable, but would open that up for maybe a certain level of video storage, CDN types of applications, as all of this continues to, push out to the edge and out to the far edge. And so that concludes my talk. Are there any questions? Yes?
Could we really combine slates and PSUs from different vendors with, for example, your chassis or WeWin chassis? Is it with compatibility and is it maintained, guaranteed? And so
Absolutely. And if you want to head over to our display, we're actually swapping chassis or sleds between chassis right now. Showing that level of interoperability.
Thank you.
Yeah. Oh, thank you.
I've got another question.
Yeah.
We talk about hardware, but also as it targets some virtualization infrastructure, what about software certification with players like VMware, I don't know, Red Hat and so on? Do we qualify this platform? We stay focused on 86, okay?
Okay. Yeah, as far as our airframe platforms go, we typically certify with Red Hat, Ubuntu, Windows, VMware. We use a lot of CentOS. That's not, there's no certification process for that, but we definitely use that in our platforms. The other sled manufacturers, I'm sure you guys will, want to follow suit and do a similar type of approach.
Thank you.
Yeah, thank you. Anything else? Or anybody else? Oh, yes.
Mike, do you see a need for advanced cooling in these edge and far edge applications?
Yeah, actually we do. So -5 to +45, +55 is, covers a lot of the planet, but not all of the planet. And, especially when we start to take a look at some of the next generation processors that are going to be coming out, from AMD, from Intel, denser solutions, higher TDPs, certainly some sort of advanced cooling solution is, maybe in the, version 2.0 of the specification. By the way, real quick, I know that we have several of the vendors here in the audience. If you guys would like to just raise your hands. And there we go. And so if you're interested in finding out more about the products, we're well represented here today. Okay. Any other questions? Yes.
Do you have any plans to start supporting the, let's say, the Facebook spec kind of service, like the Cubby or the Yosemite or those kind of things?
Well, we actually do sell an OpenRack version 2 based solution to our customers, and this is really, I don't know if you'd call this maybe the mini-me of OpenRack version 2, but we definitely took a lot of the best practices of of that platform and rolled it into openEDGE, right? The the Tioga Pass or the OpenRack, it has a a depth that is really not compatible with with far edge deployments, and that's why we had to shorten that up. But definitely, as far as the all front access, vanity-free design, toolless operations, we kept all of those all of those best practices in this product.
Yeah, that part was clear. But my question was, will you be able to support, for instance, a copy server? That could be a size server from Facebook or a Yosemite.
No, I mean the dimensions are just incompatible.
19-inch rack versus 21-inch rack.
Yeah. Well, there's that in the U versus OU. I would, fully encourage Facebook to consider doing a sled for this platform, though. I think that would be a great addition. A question in the back?
For the switch, you mentioned maybe switches would be coming. Do you is that someone's already working on them, or is that just an open call?
That's an open call right now.
And so what do you do today, or what do the customers do today if they have 2 or 3 of these units and want to connect it together?
Well, for us, it's it's 10 gig or 25 gig Ethernet. We tend to prefer 25 gig. The servers, the blades themselves, they'll support up to 100 gig Ethernet right now, and so as far as if I had an ideal switch that I would recommend for that, it would probably be a 12-port 100 gig switch. I think that's about all you could really fit on a 1U faceplate. But that would give you the ability to to daisy chain several of these chassis together.
Okay. But there's nothing today that would be compatible with your the depth and so on, right? That
No.
would even if it was a 1U.
There's plenty of pizza boxes available from OCP that are in use with the, but it's just
Right, but the form factor would need to be changed to fit into
Yeah,
that
that's what I'm
solution.
asking.
Yeah.
Okay. That hasn't been done yet. Okay.
No, not yet. Not yet. I look forward to making that announcement soon, though. Yes. Anybody else? All right. Thank you.